Static code analysis is a fancy term for looking for problems in the software program source code. If you have access to the source code for a program, you can check it directly for security problems using source code vulnerabilities analysis tools or by using your eyes and brain together. These methods for discovering programming errors in security are known as white box testing or clear box analysis. So, what is a source code? So, source code basically is an instruction describing what a computer program can potentially do, and which state analysis looks at the source code files, uh, but not program running in the memory, and the input data controls what program does while the code is running, and what data will the program receive as input. So function, method, procedure, APIs. So function contains all the code in a program. So the functions are basically the internal core to the program, and which is the reason why functions are typically accessible from the code of the program, and RPC can be accessed from outside of a program, and API exposes a program to other program, which helps the procedure of a function and APIs. So improper coding and use of function can create a buffer overflow condition, like there will be three categories of buffer overflow condition to safely function, such as the first one is the function easy to use safely is basically the safe way to use the function, and the function easy to use unsafely is basically the hazardous, which is not recommended, and function impossible to use safely is very dangerous for to use. And so we should throw away all that ancient and legacy code and rewrite the code so that we can write the function safely for everyone. So here are some of the safe and unsafe functions. So the left hand side there are the some unsafe function, and which they call the ban function, which is usually the get, stir, copy, stir and copy. And for the opposite case, the safe function equivalents are just the difference is between the underscore s and every cases. So it's better to use the safe function equivalent rather than the unsafe function. So example of a unsafe function which is sure to avoid, like in this case code is very easy to check whether your password here is within the code, so anyone can check the password within its code. But our functions are really safer, mostly yes, because nowadays they use safe coding, and developer use the boundary checking input or parameter validation, and the static code analysis finds calls to unsafe function, and the compilers warn of and even replace unsafe function so that they are safely to use and compile. So boundary checking. So for the boundary checking, the index value is 0 to 9. So code and data has boundaries. So boundary is 0 to 9 and stay within the boundary. So if we check like buffer 5, so it is within the index value, so it is good. So if buffer is 10, then it is bad, so it is a risk overflowing. So never forget to check the boundary and always use the index value and use the inside the index value. So parameter validation, so I mentioned that input validation performed aside of a function is called parameter validation. This is because data is passed to a function in the form of function parameter, and in this code of example we can see a tiny C program that contains the two function parameter, which is argc and rb. So this program displays the value of a third element in the argb contents, so argb array, which is the second argument passed to the program on its command line. So if we run this program with the following command line argument, the strength R2 would be displayed. So the problem here is that there is no parameter validation before the art where the array is used, because the program can be run with any number of command like line argument or including only one or none could attempt to display an argument value that doesn't exist, and that would be bad. So let's look back at the how to fix the problem using parameter validation. So here is the same problem. So we have written the secure coding practices in mind. First, we check the program was run within the command line and that contains at least two arguments. If this argument's value is greater than 1, then the operation system is telling us that there is at least 3 arguments in the RB array. So next, if we check the third array element actually contains data. If it does, we check the data is acceptable length. If all those validation checks are true, then we can call the printf function to pass to it the value of the second command line argument to display. So if you see the parameter validation in the same thing as input validation, we are simply checking if data passed as input to a function is acceptable before we use it. Is just a common sense, right? Is also a lots of extra code which many programmers like us don't do it. So the next, the format string buffer overflow vulnerability is caused by the lack of input validation or parameter validation. It occurs when a formatted print function is passed and a format string using a variable rather than using a hard-coded concept, which is by far the most common way to construct a formatted print statement. So if you are a C programmer, you are looking at this two codes example and probably saying to do the exact same thing, or is the big deal. But well, let's have a look at the code in the another context. In this one, unlike the previous one, the two variables used by the first two printf are parameters passed and parameter passed to the function, and you guessed it, there is no parameter validation being performed. So which is these two function calls is most likely to have a buffer overflow condition. So yes, the first one, this is because of the form at a string passed to the first printer function as a parameter is not being checked. If it won't result in something dangerous happening, if an attacker should find a way to control this input data, it could result in displaying internal memory address or corruption of data, or just crashing the program pass format string and variables. So if you must, but always check if the data is correct first. So in this lecture we'll be talking about binary code analysis. So what is binary code analysis? So binary code analysis is often referred to as binary analysis, which is a threat assessment and security assessment framework in a binary level of code. Binary assessment can help development team analyze the raw binaries of an application that comprise a complete complication, which helps to analyze the code security when there is no access of the source code. Also, it is a form of static analysis that does threat assessment and vulnerability testing at the binary code level. So, these analyses look at the raw binaries that compose a complete application. Binary code analysis is usually comprised of a multi-step approach to reverse engineer the binary by attempting to model data types, flows, and control paths using various analysis techniques. Then an attempt is made to analyze the derived model in order to detect recognized security flaws and synthesize the results into detailed vulnerability reports with actionable remediation. Basically, binary code analysis is a typical used to assess potential vulnerabilities in an application introduced in the compilation process. So, to perform an independent security audit of a third-party library without investment of the vendor, or when an analysis is needed but access to source code is not possible for whatever reason. So, why is this binary analysis important? Source code isn't always available for analysis. For example, some companies purchase firmware to integrate with the hardware in their products, and the firmware is in binary format. Another example is software companies that leverage third-party code and libraries such as frameworks, containers, GUIs, and database to augment their proprietary code. And these libraries often contain no source code. Whatever the case may be, it's still important that the consumers of these binary files understand what is inside them. So, binary analysis solution enable organizations to inspect the binary code without any involvement from the vendor to identify the open source component. Then security vulnerabilities, license obligations, and additional sensitive information that could lead to a breach. So let's now talk about the binary code versus byte code. Basically, numbers are stored in a binary form. So the minimum storage unit is a byte. So there are computers with 7-bit and 9-bit I heard, but I never worked with them though. As far as I know, already in the late 60s, the 8-bit on. So here is an example of machine code and representation in assembly language. So the left, as you can see, the numbers are the sequence numbers of the first byte of the command, and in the second column we see the byte of the command. They are written in the octal number system. In the third column, they are assembly language numerics that simplify the human perception of the program. And some commands take up to like 1 byte and some commands take up to like byte 2 or 3. So in this example, there are no commands that take up to 3, 4 or 5 bytes. In such command also occurs in here. So this is the binary code that is the processor understands. Now about bytecode, the main problem with binary code is its speciality. So two different devices such as laptop and mobile phone have radically different processor and radically different sets of commands and codes. If we want to write a program for them, we need to, I think, write a two separate programs. So traditionally the programs of portability is solved with the help of high level language and compilers. A good compiler is a complex program that takes a long time to develop and is very difficult to maintain. If our compiler supports 5 different architectures, it has 5 different optimizers and code generators. One way to solve the portability and complexity problem is an intermediate virtual machine. It must have a low-level architecture so that it can be easy to implement. On the other hand, it should include the main feature of modern processors, so as not sink in the performance. The virtual processor works the same way as the real one. It sees an array of the number and perceives them as a command to execute. The bytecode looks exactly identical to the binary code. So here is an example of a Java virtual machine bytecode. The only difference between this and this is that binary code is executed by a physical processor and bytecode is a very simple interpreter program. However, as far as I see and know, there are physical processors that can execute the bytecode of a Java machine. So the difference between them may not be quite conditional. So that's all about binary code analysis. After a while of reading your own source code or reading someone else's source code, you will naturally start to wonder if there is a quicker way to find possible security vulnerabilities. The answer is yes, and it lies in automated source code analysis tools. After all, what is software for if it cannot do complex repetitive mining tasks faster or more efficient than a human can? Automated code analysis is the process of using specialized software to read someone else's source code and point out possible security vulnerabilities for you to fix. Yes, I said possible. These tools only find possible problems. Automated testing tools comes into basic types of static and dynamic. We have already seen that static analysis, resource code, binary code, or byte code that are stepped that is not running as a program. Dynamic analysis today tools work by running the program source code and binary or byte code in memory, as it would when executing as a program. This allows the code to be run multiple times using different input data. This causes different execution paths within the program's logic to be tested or executed as a tester. As a software tester likes to see the truth is the most static and all dynamic code analysis tools that are automated in some way. The dynamic testing of software is just too complicated and complex of an operation to do manually. Besides, who doesn't like starting an automated program, going to launch, and then coming back to find all the answers that have found out for you? After finding buffer overflows, most automated testing tools use input data testing. After all the improper handling of bad input data is most likely what will trigger an exploitable buffer overflow condition. Input testing is used to check how a program will handle both legal and illegal input values. The purpose is to determine if the program behaves correctly when given either good or bad input. If a program behaves incorrectly, a potential security vulnerabilities may exist, and that vulnerabilities might be exploitable to successfully attack a program and a system. This program is running on It is thereby extremely important that all programs handle input data properly and be tested that they do. And input testing, the ability to a program to handle several characteristics of input data are proven. Range testing is test data and input as a range of legal values, say 1 through 10. Any input outside of this range is illegal and should be handled properly and not considered to be illegal value. Input data may also be tested as a fixed set of input values. Using this dataset, both legal and illegal input must be handled correctly. Input data can be restricted to a specific length of a byte characters, and passwords are often restricted to a length between 8 to 20 characters. Input data inside this range is legal and outside is illegal. Input data can also contain a legal set of required content, which we have all created password that must contain at least one upper and one lower case and some number, this and a number and a specific choice that set of punctuation characters. Input testing will check if all the legal characters inside of the legal character set are accepted and those characters outside are rejected. Finally, the input may be required to conform a specific data format, which data format either conforming or violating required data format, and this must be handled properly by the program. Input testing is a large set of range of input values, can be extremely time consuming. Testing can use a minimal set of legal and illegal input values considered the minimal necessaries for input testing. For example, to test an input, the proper handling of a numeric input value is the range of 1 to 10. We could use the minimal test set containing the numeric value like 1, 5 and 10, the minimum and maximum legal values and illegal mid-range value. Of course, this range is so small that we can easily try out the possible legal values. But what about all the possible illegal values? Well, there is nearly an infinite set of those, which makes through testing extremely time consuming, if not possible. We can use a finite set of illegal input values for input testing, but how do you know if the values you choose will catch any and all input vulnerabilities? Between performing minimal the set testing and a full set testing lies fuzz testing, also called fuzzing, when a set of possible input data is just too large to fully test or reliably test. Using a minimal set of data, a very large set of random data values can be automatically generated and used as input values. The fuzz can be random numbers, strings, or any binary data that vary in length, content, and format. The fuzzy input is literally a random input attack upon a program attempting to discover values that the program handled incorrectly. The high volume of input that may be generated require the fuzzing be performed using automated testing tools. Millions or more input tests can be performed depending on how long the fuzz test has allowed to run. Programmer, software developer, coder, software system engineer, whatever you call yourself, you need to follow software programming standard and guideline for the proper design, implementation and testing methods needs to create a stable, efficient, and resilient software-based system following industry-approved standard. And guideline will not only aid you in creating system and maximum usability and minimum security issues, but will also help you find and fix issues in systems created without regards to follow proper standard and practices. You have probably heard the terms of standard, guidelines, recommendation, and best practices. These are all things software developers must know and follow. But just what are they, and which do you use for what? A standard is a formalized set of rules, methods, patterns, and languages shared amongst the production team and used to create a uniform product. A software standard allows different teams and developers to understand each other's program code and measure it for conformity to accepted standards of quality. Guidelines are advice on how to implement a standard or a policy. For example, a standard may require that software to be checked with a static analysis tool to find potential security issues. Well, how should you as a software developer do that? The standard doesn't say, instead leaving it up to the individual software development and team to decide how to implement that detail. Someone may have published a guideline document with the instruction on how to use such a tool in your code. So if you ever find that and you are asking yourself, how do I do that? There is probably a guideline published somewhere that will tell you a recommendation is similar to the information that you find in the standard, but it's not officially sanctioned. So, does more like advice recommendation are often proposed to a standard usually created after the code is published. So, I recommendation might be that software with the ability to communicate over a network should support the use of encryption and some encryption standard to use. What also be recommended? How do you design implement and design a encryption in your software? I'll bet there is a guideline for that. And finally, a best practice is a type of recommendation that has shown through trial and application to be generally the best solution to a problem. A best practice may contain step-by-step procedures like a guideline, or it may also be very abstract like a standard can be there, and also best practices for managing a global enterprise and level software development team, and for these best practices for help to keep workspace tidy and efficient. When trying something new, first look for the practice as a document to learn from the trial and error of other people who tried it before you. Where do you find standard recommendation, guideline, and best practices for secure software development? So I will give you a hint. I find them in a place that start with the letter of G, and all you know, it's Google. Okay, so we'll have a quick look at some of the more prominent sources of information on security and coding practices. So the source code development and standard and practices, the mostly unsafe languages are C, C++, and assembly. So the better is to use the safe language like Net Framework, Java, Perl, Python, Ruby, and try to better to ignore the unsafe function libraries and APIs like star copy, like etc. And better to use the save function and APIs. So Software Engineering Institute mostly use C, C++, Java, Windows and Android to set a certain coding standard, which are rules for writing secure code and recommendation for improving software security. And these are the top 10 coding practices, and the most important are, I would say, 1, 6 and 7, which is validated input, adhere to the principle of least privilege, sanitize data sent to the other system. And also content web app security flows, mostly like A1 injection, A2, A3, A4 to A10, and Microsoft security development lifecycle, which mainly reduce both security vulnerability and reduce the development cost, and which is helpful for Microsoft's trustworthy computing initiative, and for the purpose of security, privacy, reliability and business integrity, and which SDR released to public in 2008, and following the SDL standard is recommended for all organizations development software for the Microsoft Windows environments. So who is responsible for the security code? So I would say the software developers, because the software developers who secure design and coding practices, who always range checking and input checks, the input validation, and better to not use the unsafe calls or code libraries, and use the programming tools for the safety features, choose language that may buffer overflow impossible to occur, and review code for potential buffer mismatch. And obviously the software testers, so software tester who does the black box testing and test all API inputs, and also same as the software developers checks the range checking and input validation, and use a wide variety of data types for input testing, and work the overflow condition without data input. So also software testers does the developer producer for reliably reproducing the errors, and finally also testers should talk to the software developers to secure the codes. One of the most interesting places to look for buffer overflow vulnerabilities is in the history of malware. The possibility of input data overrunning the boundaries of a fixed size area of a computer memory has been known since 1950s. When computer first started storing data in random access memory, malicious software really didn't appear in public until the mid 1980s. And then only one of the many mainframe computers, but it soon spread to personal computers, where proof of concept like malware were easier to develop in test. This movement of malware of personal computers like also gave birth to the antivirus software industry. Today we look back to see some of the most famous and memorable examples of malware in the past 30 years, and that has exploited buffer overflow to achieve its purpose. So in the beginning, the Morris worm of 1988 was the very first significant malware event on the internet. This worm propagated across the internet using the three different methods, one of which was zero-day buffer overflow in the Unix finder daemon. Finger is a Unix finder which used to obtain information about the user and the user accounts, and the daemon is a process that runs in the background on a Unix system on Windows. You know them as called now is services. The malicious worm exploited an overflow condition and a 512 bytes buffer, and that allowed the instruction pointer to be redirected to run the Bonchen command, effectively opening reverse shell back to the attacking system and giving the worm access to the targeted system. Nothing much happened publicly in the way of buffer overflow vulnerabilities until the early 2000s, when the code red worm of 2001 suddenly appeared, and the code red worm was able to infect Microsoft Windows computers by exploiting a buffer overflow found in the Microsoft Internet and the information server web server versions 4, 5 and 6. The vulnerability was where the IIS web server communicated with the indexing service in the IIS search engine, which was enabled in IIS by default. This exploited was reliable and allowed full access to the Windows server. Its existence was actually revealed by Microsoft as a patch to fix the vulnerability over a month before the code red appeared, and the code red was the first major event showing the security patches, and these could not only be reverse engineered to discover the vulnerabilities and they were mitigated, but also that malware could be crafted to effectively exploit that vulnerability. And the code red also demonstrated that recovery and restoration from a large scale malware attack could host billions of dollars. And code red wasn't the only one to exploit this vulnerability by IIS, and the variants of the worm soon appeared and were dubbed as a code of red, code of blue and code of green as the different payloads and objectives. This was also proof positive that malware itself could be reverse engineered, reposed and redeployed with effectiveness. And this was also released by Microsoft and it about 2 weeks before. And the next Windows wormholes from the past, which firstly appeared as an IMDA in 2001. Then the next one was Volgimo in 2003, and the third one is SQL Slammer also appeared in 2003, and also Caesar the very next year appeared as a Windows operating system. So it doesn't just end here. The Microsoft Windows also occurred and decom the RPC interface button overrun. Also Microsoft Windows Web Dev buffered the overflow, which LS and AS service overflow the system. And also after the 2003 exploiting basically the same buffer overflow vulnerabilities in Microsoft Windows, firewall not running all processes with system level privileges and immediately applying security patches as they were release practices. We know today to be a no-brainer with the Linux and the Unix operating system have not been spread the presence of a malware exploiting buffer overflow vulnerabilities, either worms and other malware seeking to run code and escalate. Privileges have attacked these symptoms like the system since the Windows natively spoke the TCP or IP today. This is still a concern because most of our Internet of Things devices that talks about the Internet runs the Linux or Unix operating system. If we were to continue moving forward through malware history, we would notice that the attacks using buffer overflow seems to be diminishing. We might expect that the increased awareness in computer and information system security and the use of proper coding and testing practices have all but wiped out exploited buffer overflow vulnerabilities. And looking at the dissembled working of modern malware such as Stucknet, Duku, and Flame and CryptoLocker shows various sophisticated malware that do not use buffer overflow exploit at all. However, buffer overflow vulnerabilities are still out there both in very new and very old program releases, and modern malware is still exploiting them. So, for example, the Zeus banking intrusion first appeared in 2007. Although Zeus relies on social engineering to interact the system, but once installed it uses like a known buffer overflow flows like in Adobe product and Microsoft and ActiveX to steal like our bank credential and a username to perform a key logging on user input, and these 2011 and 2013 variants of Zeus continue to exploit buffer overflow vulnerabilities when possible. The heartbeat vulnerability, the SSL is an input validation error very similar to the type that allows buffer overflow to occur without the owner's knowledge or permission. Heartbeat is an excellent example of how the lack of simple input validation can create a buffer overrun vulnerabilities with potential severe consequences like privileges. The 0-day vulnerabilities have been present and exploited on most Linux systems worldwide for several years. Defenses and that prevent a buffer overflow condition from becoming exploitable and have made this vulnerability much less of a successful attack and likes of vector. And nevertheless, the advance of persistent efforts will eventually find a way to any defense created to safeguard a flaw from attack. So you have statically analyzed the program source code and perform a binary or the code analysis on the program's executable, and may have used some dynamic analysis tools to test the program. While it is running, you now believe that you found a security issue in this program, but you cannot find any reported the issue in the program release note or bug tracking system or the program author's website discussion forum or any of the usual vulnerabilities or exploit database. Even Google search turn up. So no one talking about the problem. So what do you do now? So what reason you may not find any public discussion on the issue is that you haven't really found a problem, or at least a problem causing anyone to complain. Consider that you may be misunderstanding how the program operates or misinterpreting its input or output. It might be something that looks like a problem such as an error message, but it's really not an issue that needs to be corrected. You can also find a genuine problem that is very minor and not potentially a security issue. If any of this might be the case, what you need to find is I would find a public discussion forum and related to these types of problem and ask what other people think about it. So if you want to keep your discover private, just in case it's really a serious exploitation bug, then email the program developers and ask them about it. Then obviously the developer will give their preferred method of contacts on their program website. But if you decided to report the bug, you can just look at the contact information for the software developer. So send off an email, I guess, hopefully to receive the thank you in return. Maybe go and talk about it in some public forums and let that be the end of it. However, if you have discovered a problem that potentially serious security consequences, then you will need to take care of it, so you can report the issue and how long you keep the information confidential. And yes, security related software bugs should not be immediately disclosed to the public until a patch of the problem is made publicly available. So also there is some rules for the disclosure, like privately contact the program's developers, owner or maintainers. So and use the reporting method to specify by the program's owner, and do not make a public problem report unless you ask to do so. And because of that, mostly use the reporting format is specific by the program that owner own, and also provide instruction for duplicating the rules, and give the program owners some time to respond to your report. So you have to keep patient. So and also work for the program developer if you asked, and report to a reputable white hat vulnerability organization at the end. And for the full disclosure, encourage user and security research to look for exploitable vulnerabilities. So and for the owners, you need to fix the insecurity system and spread awareness of vulnerabilities to prevent them in the future. And also the dark side of the full disclosure is that black hats will become aware of the vulnerabilities and cap exploits for them. And also civil actions for damage against vulnerability will be discovered, and it will be all public. So it's better to be private disclosure to the problems owner or programs owner, and it should be the ethical behavior is the, I guess, as we call, the best defense. So vulnerability database and repos. Vulnerability buffer and information about the buffer and overflow vulnerabilities that have already been discovered and made public can be found in various of sources. These sources are often called vulnerability dictionaries or databases, and contain reports of tested and verified softwares flaws that can result in security related consequences, like each report details and design, implementation, configuration or user issue of a software or hardware system that can present a exploitable vulnerability or expose information. Vulnerability tracking databases are often found in a variety of public places and private websites. Of course, you can just try like Google, but narrowing a searches to a specific vulnerability databases may speed up your finding results. So let's look at the few places to find a buffer overflow. The most universally recognized vulnerability report is the Common Vulnerability and Exposure at cve.mitri.org. The CVE is a dictionary of public disclosure software, which is a vulnerabilities and information exposure that have been discovered and reported by the software vendors and also White Houses. and security researchers, and is usually in the form of references to other documentation. You won't find any explicit vulnerability details in the CVE reports themselves, and only information used to compare the vulnerabilities. Like the CVE dictionary is like freely available online for worldwide. Use the CVE uses a uniform identification and a description system to maintain consistent reporting of the information. Like each vulnerability added, the CVE dictionary is assigned to a CVE ID, and these IDs are called CVE names or CVE numbers or just CVE. See the EID number and the year of the order the CVE was published, and as a reference to a single vulnerability in a specific public software distribution. There are currently over 75,000 CVEs IDs and published since 1999. So finally, when searching for software and system vulnerabilities, information was sourced that may not occur to you vulnerability because of the exploit databases. These are the information about how to exploit vulnerabilities and software systems. These sites makes available hacking tools, exploit code, and hacking tips, and all sorts of security research and paper and documents, vulnerability and exploit blogs, and even a discussion forum. Don't be surprised to see that they offered a buy and sell of both vulnerabilities and explain the exploits in both sites. So if you are a white hat, these sites are invaluable researchers for aiding you and not only testing for the presence of specific vulnerabilities, but also inducting hot source of information and capabilities. And the black hat community has access to remember that information itself is not evil. It's what you do with the information that determine your moral and ethical behavior. As we explained what is buffer overflow, so now we need to do a proof of concept regarding buffer overflow. So we need to start by asking, how do I know that such application has buffer overflow, and how to utilize those powerful overflow weakness to be able to get access to the victim system, and then to identify which application has the above rule of law. Now we can do that in two different ways, in three different ways. First way is by searching, so from the section related to scanning and resurrection, and by getting information about your victim, you should also know some application that run on the victim machine and could be an operating system that may have, and what does our XP, Windows 7 or Windows 8 or Linux, and you may able to get some information about some specific application running. So we have a specific version of appropriate reason or any other software, and then we start searching about those application. And we already explained that in previously that you can go to the some of the website, like for this one, Security Focus or Security Tracker or some other underground website, where then that will explain actually what phase and what you will be searching until you find that one of those application is about. For overall, there is only way for doing that is by searching, and by searching you have to first install a virtual machine in your main computer, because it's very unsafe to use Boom to your main computer. So it's better always recommended to use the virtual machine, so it doesn't affect any error in your main machine. So first you have to do is use and download Boom and install this obviously in the virtual machine and run as a port 4321 for the connection, and type the other machine's IP and port for the connection. So there is only one way for connecting. The another way for using it is, so you can type 10.net space the IP dot space or a port number, then it will connect to this open port, and as you can see in this picture is connected. So whatever you are writing from this upper picture or this one Boom, it will be also shown in the other machine. So if you write here ABCDEF and it goes to the other machine, so you're gonna find ABCD also in that. So other information that has sent are saved in the hard drive. No, they are not saved in the hard drive, they are saved in the memory. So this application is accepting variable from user remote and it put them in the memory. So there is another application called fuzzer application. So a fuzzer application that is used for fuzzing, and also we are going to use a specific fuzzer application called spike, and we are going to do a spike, and as you can see in this picture that you can just choose a character that will keep and send the victim machine until it crashes, and one way just doing is to just keep trying, and so as to try to copy, and which is called ability to spike in. Now what this command would be doing, it will be send this file what you created in. So we are going to change the ability to seek it, so seeker library, and also the keep is sending any of the server to this port until it crashed. So it will send the TCP traffic and it will keep doing it. So generic will send the TCP and then the IP, and then have to type the port number which is fixed 4321, and send the filling which is a seeker dot spk and double 0 space 0. So okay, let me just summarize it and what actually it is. One will this do is that it will tags are like file seeker, and this will literally and keep sending this letter to the specific IP through the specific port and sends the other device. And one is a application that keep accepting, and another is putting inside memory, and it will keep sending those letter until it overflows. So what happens is, if after the system crash, like this means this is overflow, so that means it is infected with buffer overflow, and which is this if it shows, it means it crashed. So but it stops after a while and it's not accepting, means there is this application is not affecting both overflow. So we need to do is run the application to the victim machine. So what to do is, we need to go here and run seekable and go back to and run it like this. And so as you can see, you kept sending until the application crashed. So as you can see here, the application crashed. So exactly in this application, who used to accept input from user remotely has stopped working, because he was taking this input to a variable inside the memory, but the variable was not defined. So he kept the receiving end and he crashed, so it overflowed. So as now I can say the application is affected with a buffer overflow. So in the previous one we used the fuzzer application from the backtrack, and that was sending a big amount of information to a vulnerability application on Windows machine until it crashed at the end. So we are able to identify that the specific application has a power overflow. So, but what we need to do now is to utilize it and how to get the advantage from that. So firstly we need to analyze it. The first piece of knowledge that we need to know is that how much we collected and how much A need to be crashed of the system, and where exactly those A has been sent and where the critical area of the memory. So the first thing we need to know is how many A led to the crashing of the system. So to able to do that, we can run an application one more time, and we're gonna repeat the attack, except this time we will not run the application of the buzzer at the first. So we're going to use the Wireshark application and to able to capture the quarter of a build, and Wireshark is a application that built in Linux. So we can open the application and start capturing traffic and repeat the attack until we wait until it crashes, and then we are going to try to identify the amount of traffic that led to the crashing. So we are going to go to the capture interface and capture it at the Wireshark application. So and then back to the computer to run the application number, and it will send the system crash. So now we are going to try to identify the amount of traffic that has been captured. So as you can see, like now we are looking for all kinds of traffic that will send to the computer to the other machine. So we need to first to know what IP of the backtrack machine. So as you see in this picture, they to be able to trace the what we just maximize the size and let the terminal. So what are we going to do now is that we are going to analyze how much air they let and catching the system, and because this is very important for those at that. So the hacker machine at this picture at end up at 95.130 IP address, and the victim machine that was 95.37. So we need to check the source IP at this software Wireshark, and check the source IP on the series 7, because you can put a filter in this IP, and you can search for the IP that you previously got from this page. So we're gonna talk about this option in the next lecture, in full description. So now we know that the Chikaboom application is vulnerable, and if we send to the application 5000 or A or B or whatever character, and it will crash. So if this application do not validate, then the input, and accordingly I can get the benefit or utilize the compromise with this. So how do we do that? So now that I know the important number is 5000, so you should be aware that about how many characters you need to crash the system, or so we can start working on that. So we need to first analyze the specific attack with something called the debugger, and there are many debuggers on the online, and we send the virtual machine where exactly they have sentence, remember, to be able to do that we need a debugger, and debugger is an application which will show you the memory, and there is a lot of debuggers, and the debugger is best to use is the immunity debugger, and there is already backward and many of them, but immunity debugger is the suitable because it's quite easy to use. To repeat this attack, we need to analyze where exactly those will be saved inside the memory. So here's what we're gonna do with the immunity debugger is this. We'll download this from the internet and we'll run the immunity debugger, and after running the immunity debugger you have to use the Boom to match the connection. So we need to verify this application where exactly serves the moment. So you're going to see with lots of hexa and assembly stuff like that, and this is actually doesn't matter, so don't get confused with that and don't worry about the anything else, because we're looking at the specific input in this immunity debugger. So once you do that, you notice that by the default you will be noticed that it paused, because by default it will pause the application. So you need to run the application. So you run the application, then it will be turned on and application will be running, and we will have the immunity debugger in the bugger monitor. Then we will crash the system again, but this time we can see exactly where, because those error will be saved inside the memory of a vector machine. So now after running the debugger and the associate that or HRs that my application return sends the 5001, as you can see in this picture. Then let me show you the script one more time and let's see what we are going to have and what will happen. So this sends a GCP and the IP of the vector and the support, which is the port is 4321 and the final name was the .spk. So there is a folder that have a small script that was from the internet, which I am showing you. But if you went through the main comment, you will be able to understand and modify onto it. So let me tell you what exactly the script is doing. As you can see the hash here, you can fix the script, and this can be used for any kind of buffer and the buffer overflow specialist that talking about. So here we can see buffer, and we are going to put the same black slash, then the clash exportian, and then close it by multiply by 5000. So what exactly is this? Comment is doing this for creating a variable by the name of buffer. So because it creates 5000 AR x41 and it's a letter in the hexadecimal, so it creates a letter 5000 and it's sent to the vector member, and the vector will be cached if you receive 5000. So this is exactly the script is doing. So you need to just create here and change the right IP, and once then the right port 321, and you remove that and the hash function, and this will be like the workflow. But this will not be executed only in the test, but it will be executed in the PUI, and it will be sent to the buffer. And let's see after using this the system crash or not. So as you can see in this picture, it crashed. So it crashed the application and the process. So as you can see, it crashed. So when it crashed, it seems like the application is not reachable anymore when at this state. So this is actually means that big amount has been crashed. So inside the memory there is only one the right side and check the different values. So the EIP which is this value, and EIP usually contains 4 character. It's a very important. There is actually one core subject about this, and EIP here overwritten with those, as you can see, 41 41 41 41, and they replace with those by forward 41, which is a. So the first value that we are checking inside this EIP and EIP is an location inside memory that holds 4 character, and it usually holds the first 4 character that any problem and that need to be executed. So whatever you can put here, if you can put the first 4 character from any application, that means it will be executed. So this means it's very important. If I send the application and if I able to adjust the force character and the application, so to be inside the EIP, it would be executed. So the first value that we focus about the EIP is the second value, and which is the ESP, and the ESP is a pointer that point the remaining of the code. So if you check here in this picture, the ESP has been overridden by the A as well. So at this point, most important part is the memory, and it's a location called EIP, and it's a pointer called ESP. And if you buffer overflow, and it will be able to overwrite itself, and that means that you can control the memory and you can send them, and also you can payload with any malicious code. And if you adjust them to be sent to this location in a specific way, it will execute what exactly you are going to request. So, and this would be the, I guess, next bit, and you are going to see how to remove this and put the specific route and adjust that, and finally it would be executed. So to the final stage, which is modifying those A and replace them with specific payloads of a malicious code. That will give us the access to the computer since we are not able to reach those critical places inside the memory, which is AIP and EIP and ESP. Now the first challenge that we have is that we send those 5000 A, which is one of those overwritten here, and the EIP memory and can have 4 character. If you control them, if you get access to them, that's it, you don't need anything. So you need to know which has a overwritten, because if we send 5000, it could be just first 4 and the second search. So we need to identify from those 5000 A and which A is in overwrite to EIP. So I can do that in different way. One way is to keep them in a system. So I can, for instance, type or send 1000 A and 1000 B and 1000 C or 1000 D and E. And if the EIP has been overwritten by P, for instance, that means the 4 character are the existence. The second 2000 C or but I think this will take some time. Second way, actually it will take more than 8 or 9 try. So the best way is to use the specific tools, like let me show you the code at you can see in the screen that it can meter the speed. So we can go for the penetration testing and exploiting it to the framework, and the framework series there is a folder called tools, and on tools there we have something called and create to comment pattern, and we are going to take the amount of pattern that we need to be created. So we can write 5000 1 2 3 and we go to the enter and it will create a pattern of 5 star. So these 5000 we are going to take into and select all of them, and instead of sending we are going to send those 5000, and we are going to copy them and go with this. And instead of sending 5000 we will be send 5000, but instead of sending it will be sent as a random number. So as you can see, it just created a random number in the buffer hashtag buffer line. Instead of using the 5000 we just use the character. And for run the script, let's see if I am going to send those 5000 character instead of a, and let's see if I say that I should replace the EIP, then with the B letter we can replace it with the ESP and replace to select. Then there will be no more authority and there is a line. The EIP has been written and has been overwritten with B, as you can see in this picture. So that's mean I was able to identify from just 5000 and which 4 character would be overwriting the likes of EIP and ESP, and helping those line to written and better to see. So I guess everything is okay, and now we can utilize the script to, instead of sending A and B and C, we can send a payload and get an advantage from that. That's it. So with the previous one we were able to adjust the script so it will exploit it, and the Sikaboom application, and it will buffer overflow this application, and went through how to adjust a part of the buffer overflow to go to the EIP, and especially those 4 character apart from the ESP. And actually the EIP is the most important one. So this is the script from the previous video, and if you remember the first 263 character, this should be going everywhere, and after that it will have a buffer overflow, and then the 4 character after that which was expected to be B root and the B whatever remained from the 5000 here, and it has written on the ESP. So what are we going to do? That we have to remove the source A, B and C, then we are going to write or use the exploit. So the first thing you should do is to need to put on the ESP's payload from where we can get the payload. So a payload can be and get from a different ways, but we have a very good tool in Backtrack actually, and it's a tool that allow us to generate a payload. So it would be written in the ESP port, so it can be here from the penetration, inside meter or framework version in the web. So we already explained previously that use of the exploitation part. So now we use the RPC exploitation to exploit the system, and so that we can browse the type of IP and showing this to the command line like in this one. But we mentioned that total size should be always 5000, so there was a little less, so it should need to be executed from here, and the total amount should be 5000 from 416. And for the first point is that the usually the first shell code, so I have to put around the 16. So it is important because according to that it will leave some space to be executed, but don't forget that we need to do the ESP, and also ESP would not execute it by itself, so the SP is being executed by the EIP, which is just 42. So in this part the EIP need to be put a specific register which is a specific entry that will enforce to execute the ESP. So usually having memory called a jump PSP, and the jump records that enforce execution for ESP. So if you are able to get this jump ESP, and it can replace those 42 jumps that you saw in the previous picture and the code, since this is a place where the memory executed the entry. This will happen when you send and find the jump PSP, and it will send to the memory. Then it will automatically go to the ESP and will be executed. And this is very important because this is what will send to the EIP, and according to that EIP would be automatically go and execute. So what is ESP? So if you need to search for the jump PSP or code PSP in Linux, there is a inbuilt application named jump ESP. So after opening it, if you execute the code, there will be then buffer, and there will be the code that go to the ESP to run it. And as I see here, it was a 42953, and double check the 9353. So if you think to that the jump ESP value, then it will be able to use it later. So let's just wait for the next step, which is the final step to utilize this PHP. So it will be execution for instead of 42 just for the EIP, because this is what controls the execution and the valuation piece, and it should be written on a specific way like the opposite ways. So for this instance, if you put E and it will be 7E and move it to the 704240, and then 93 dot, so 93, and finally C is 42, and finally 5353, so 53934270. This is the jump PSP. So if everything went well, that's what we expect after this. Then there is a port which is 4444 open to the vector machine, and virtual machine, so it controls the application and make sure to go back and open the application to utilize it. So finally we don't need use the debugger right now, as we access the virtual machine or not, so it's better to just open this application and up and running. So this was the nice script that created over this. So as you can see, you can check it from the Windows machine, or also use the netcode to open the code, and finally utilize the buffer overflow to get the full access of the machine, and a port should be open. If it works, it's fine. You can just check from the Windows machine, so you can netcat and try to cover up into it. So as you can see in this picture, it created the payload that I sent, and it utilized the buffer overflow to give full access on the machine. So in the previous one we explained how to utilize the buffer overflow in an application and remove those characters like random characters A, B and C, and send the specific payload to compromise the system. And we saw how to utilize the important location in memories like EIP and ESP, and I'm going to tell you how to replace the payload, put another payload, or customize the payload. So I'm just going to choose another payload. So let's get back to the script, and let me choose another script like this. And because this one is my previous script, so I need to modify the script by I need to get from the internet. So let's go there, and I choose this one so that I can connect using the netcat or telnet or anything. So we are going to go to the payload, and we are going to choose this for the reverse shell, and we are going to create connect to our machine. So we need to create a payload, and never forget to get a size, because the size here is 320, and because as we saw that this is all the payload should not exceed 5000 size, because it should be always 5000. And I'm going to take that code that I showed previously, and I'm going to replace the original code. So let me remove the original code, and I'm going to create the reverse code. So in this I remove the previous shell code, and which is the Windows bank code payload, and I'm going to put the reverse shell payload. And what will be the next step, as you guess? So adjust the size, and because the size of the every payload is different, so just paste it, and you need to just make the adjustment. So every single would be same except for the size, because if you remember the previous payload, I believe it was the 300, but it was now 317. So you can check the previous lectures. Well, now this one is the 312, so this means we need to add 5 here. So it will be 12,000, and we can save it through the X. So we can keep the everything, because the same nothing changed until it's still going through the PSP. So the code will be the same. I just change the payload, as you can see here. But the specific payload, what will happen is, if I launch it, and it will be work successfully, but it should be also connect to my machine. So this is a good technique to bypass the firewall. So I need to open a port to listen to this port. So Before running this exploit, I am going to write down this comment to C-NB LPN support. Number 4, as you can choose as any port as you want, and now it's listening the port. You need to listen the port. So also run the application on a victim machine, and now I'm going to run my script here, and everything went well. So as you saw in the picture, I have a reverse connection. So after running the script, so there, as you can see the other shell, and you can see the reverse shell has been connected, and as I am connected to the victim machine. So this is how to change the payload and customize the script the way you want, because if everything goes well, then it should have a reverse connection. So we did 3 different kind of buffer overflow attack. Actually there is only one type of overflow cause. Buffer overflow is a very big subject, but so objective of this section is to how to utilize the memory and how to get advantage of the buffer overflow. And when explaining a specific application, which was Zikaboom app on the previous videos, I'm going to just show you the another application that I will not go to step by step, but I'm just going to review the application and how this work and what will be done with it. And I'm going to show you the code, and I like to have a deep look on the code. So I'm just going to show you the script, which is this, and we can use that and customize it, and it will be able to compromise the system. And the application name is ability server. So this is a server, some small software that you need to install on your machine, and it will transfer your machine to an FTP server or else it has a lot of function like email server, FTP server, different kind of services like HTTP. So it can transform your client machine to an HTTP server and browse pages or email or activity or of this specific version, like version 2.37 was infected with buffer overflow. So what happened is to utilize the same script that I create or modify and be able to utilize, and with the utilization, so it should be able to test it to able to buffer overflow. And after testing the application, you can check any website or any security website searching or for information about this application, and you can end up with this script. So first one is to share the code, and we have the value. As you remember, the value is the jump PSP, and we have the buffer as 965A, and send the jump PSP and then 16C and the 16A, and now byte, and finally the share code and whatever remaining from the code, because the total number of buffer was 2000, not like a previous scenario, but the only difference here is this script that this application request authentication. So you can see that there have a couple of flying here that you log in to this specific machine with this specific IP and specific board, because the FTP will convert 25. And when you log into this machine, there will be a server and it will request a username or password. So the next two steps will be just enter the username FTP and password FTP. So not the same that you need to have an account on the server, but to be able to compromise, you just need to sterilize the tag so that all the step is to same except the application request. So some application and authentication have two common here and two lines that are related to this authentication part, entering the username FTP and password FTP, and according to that, if we run the script, it should have an open port because we will choose the Windows bind shell and we will be able to connect. So just the make sure, as you can see, the script is working. And if I just around the script and I open and use the NC, because this is definitely a port, and hopefully a port have been opened like 192.168.95.137 and port 4444, and here we go. We have access to the machine, and I hope buffer overflow is explained well. And buffer overflow is good for to learn, because this is one of this like a good skill that you should have.
Hello everyone, let's talk about buffer overflow in Kali Linux machine. So what is a buffer? A buffer is a sequential section of memory allocated to contain anything from a character string to an array of integers. These buffers typically live in RAM. Computers frequently use buffers to help improve performance. Most modern hard drives take advantage of buffering to efficiently access data, and many online services also use buffers. Buffers are designed to contain specific amounts of data. Unless the program utilizing the buffer the buffer has built-in instructions to discard data. When too much is sent to the buffer, the program will overwrite data in memory adjacent to the buffer. What is a buffer overflow? A buffer overflow or buffer overrun occurs when more data is put into a fixed length buffer than the buffer can handle. The extra information which has to go somewhere can overflow into adjacent memory space, corrupting or overwriting the data held in this page. This overflow usually results in a system crash, but it also creates the opportunity for an attacker to run arbitrary code or manipulate the coding errors to prompt malicious actions. In 2014, a threat known as Hard-Held exposed hundreds of millions of users to attack because of the buffer overflow vulnerability in SSL software. In a simple program, you may want the user to enter an email address. Therefore, you create a string variable. You allocate 64 bytes to the variable because you do not expect an email string to be longer than 64 characters. You do not check if the length of the entered string exceeds the size of the buffer. As a result, the user enters 100 characters and the remaining 36 characters are stored in a memory allocated to another variable. In most cases, this leads to a simple memory segmentation fault, but it may have more serious consequences. Program behavior of the program may change as well. Look at that. Linux buffer overflow with shellcode. So what you need: a 32-bit Kali Linux machine, real or virtual. The project works in a very similar manner or Kali. Purpose: to develop a very simple buffer overflow exploit in Linux, writing very simple C code, compiling with GCC, debugging with GDB, understanding the register steps, and SEIPs, understanding the structure of stack, using Python to create simple text patterns, editing a binary file with hexdate using a NOP cell, and observing ASLR address space layout randomization is a defense feature to make buffer overflows more difficult, and Kali Linux uses it default. To make ASLR is enabled to execute this command: echo 1 proc sys kernel 1 randomize versus space. In the terminal, just look like this. Each time you run the program, ESP changes as you guys show as shown in this video. Disabling ASLR. Fortunately, it's easy to temporarily disable ASLR in Kali Linux. In the terminal, execute these commands: echo 0 proc sys kernel 1 randomize versus space. So creating a vulnerable program, enter this code. Simply enter this code, save the file with ctrls plus x and enter. Execute these commands to compile the code without modern protection against stack overflows and run it with an argument of a, and using Python to create an exploit file in a terminal window. Execute these commands: nano b1. The first line indicates this is a Python program, and second line prints 116 a characters. And next we need to make the program executable and run it. In a terminal window, execute these commands: chmod so overflowing the stack. All the command and all the procedure is shown in this video. You guys just watch this video carefully and try by your own. Here I give some code also. Many options and many dependencies. I'm also running an exploit in this tutorial against a vulnerable version of war FTP and SL mail. I found out that if all else fails, you use exploit windows. So here is a basic Python code about buffer overflow. Just look at this code. It is necessary for buffer overflow, and this is a Python code. Any application that takes user's input needs somewhere to store that user input. This requires the application to allocate memory for storing this user provided data, and this is buffer overflow. Vulnerabilities occur when memory management goes wrong. Before data can be stored in a chunk of memory, that chunk of memory has been allocated. This means the program needs to know how much memory to allocate in advance. Too little space. To be exploitable, a program needs to allocate less space for data than the maximum size of the data, and this commonly happens when developer makes a reasonable assumption about the amount of space needed for a particular type of data, or when an attacker exploits an integer overflow vulnerability in memory allocation. Storing too much data. A buffer overflow vulnerability also requires the program to try to store more data than fits in the allocated space. This can happen when data is copied until a null terminator, or if a developer miscalculates the amount of data. So buffer overflows can be exploited for a couple of different purposes. Using a buffer overflow vulnerability to a cache program, Python libraries need. The core Python programming language is powerful and easy to use, and the massive number of libraries available makes it even more so. Python's libraries are valuable for buffer overflows exploitation because they can help to provide any functionality required to make the exploit code interact with the target application. Python string multiplication. When exploiting a buffer overflow vulnerability, it is often necessary to create and exploit a string of a precise length. This may include sending hundreds of thousands of padding characters to overrun the buffer length. Python's string manipulation makes building exploit strings easy because a simple command like a500 creates a string of a characters to fill a 500 character buffer, and this string can cause program. So this is it, guys. Hope you guys liked it, and thanks for watching.
So guys, we're going to learn the basic of cryptography. So to learn the cryptography, you have to understand and learn the what is cryptography, how it is works. So first we're gonna learn and understand the cryptography. Like first we're gonna learn the basic of cryptography, then learn the cryptography in a nutshell, then PGP. We will talk about PGP explanation, which means pretty good privacy. So we're gonna use this to explain. Then we're gonna use the GAC explanation. After that, we're gonna learn the side channel attack. Then DSA explanation, which is like digital signature algorithm. So we're gonna also explain that. So and after that we are gonna just breaking down the outline at the end. So what you have to do and what you're gonna learn is the best tools. After that, the best tools for doing the cryptography. So the main the most important two tools are the SSH and hashing tools. So we're gonna use SSH tool on Kali Linux machine for testing purposes, and also we're gonna use the hashing tools for doing some cryptography, and we're gonna also use more tools and documentation on cryptography using other tools except these two, which is SSH and hashing tools. So the other tools will be like CryptoKit, etc., like this for documentation on cryptography. Then at the end we're gonna learn and we're gonna just demonstrate the real world example of cryptography. So we'll learn and understand that at the end. So that's all about the basic of our basic to advanced cryptography, and we're all gonna learn about this. Cryptography. Well, you may think this seems like a real short course for a cryptography. Well, it isn't. We're going to do things in a very different. In fact, I think you are going to find this is going to prove even better. Now, let me just start off by saying that if you are planning on taking the CEH or the Certified Ethical Hacker exam, and you are the list of topics for cryptography, then I have a way for you to cover all the topics. But if you do it the way I am going to show you, then you will also be able to get more information that will help you to understand cryptography a little bit better. Basically, this is a beginner guide for a cryptography, kind of like a cryptography 101, but in the material I am going to talk about, and it's going to take you a little bit further down the road, and which can help you to understand and definitely take care of all the requirement you may need. So if you are looking at the exam, but I also wanted to able to give you the material that would help you in real life as well. In whatever business you may be in, security professionals, cryptography will help you to do things as well. So here's what we're going to do. So we're going to start off by getting you the path on how to learn the cryptography, and as I said in a nutshell, it's a very extensive, but we're going to have a extensive list of things for you to learn to know, like what is a hash, how do we protect integrity, why do we protect integrity, and how do we encrypt, how do we decrypt, and what are the different ways to do all of these, and like the way public inspectorate and PKI and how the certificate works. So we're going to get all the information you need, and so I want to show you how to start off by in each right and get that taken care of. But I also want some people to kind of pick and choose the information they might want to get and learn. So I also wanted to give you a breakdown of the common topics in this outline. You might see for the CH exam and points you the specific location to get the information. But if you just brush up the something and then I give you the guidance and what to do next after you completed that, it will be very helpful for this course. So let's just get started and learning cryptography in a nutshell. So when it comes to the information security, the side of cryptography really focuses on the confidentiality side, protecting our data from unauthorized user, seeing what the data is, and the integrity makes sure that the data didn't get altered or changed without us noticing it. And that's a very important part that a lot of people sometimes forget, and cryptography helps us with it. I mean, imagine somebody going in and changing your payroll data. Now, of course, if they increase your salary, that will be a good thing. But if they decrease your salary, that wouldn't be a good thing, because availability is sometimes with risk management, and a high availability system makes sure that the data is available to authorized user when they need it. And that's not necessarily the focus of the cryptography, but it's mainly the confidentiality and integrity. So now there is a couple of topics in ethical hacking. Now we talk about the cryptography. We also likes to talk about the involved attacking and some of the ways to prevent those attacks or prevent those attacks from occurring. So cryptography in a nutshell is like talking about the confidentiality part or integrity part or availability part. So about the confidentiality, it measures and protect information from unauthorized access and misuses. Most information system house information has some kind of sensitivity, and it might be properly business information that competitors could use to their advantage, or personal information regarding a organization's employee, customers, or clients. And integrity measures protect information from unauthorized alteration. So these measures provide assurance from the accuracy and completeness of data. And it need to protect information includes both data that is stored on the systems and data that is transferred between the systems, such as email. So in maintaining integrity, it is not only necessary to control access at the system level, but to further ensure that the system user are only able to alter the information that they are legitimately authorized to alter. So in order for an information system to be useful, it must be available to authorized users. Availability measures the protect timely and uninterrupt the access of the system. So some of the most fundamental threats to availability are non-malicious in nature and include the hardware failures, unscheduled software downtime, and the final network bandwidth issues. Malicious attacks include various forms of sabotage intends to cause harm for an organization by denying the user information or access to the system information. So this topic has been let's say always a challenging topic. There are two sides in this coin and both sides are right, and it's an argument and a discussion that hasn't gone away for very long time, and I'm going to give you a couple of recent example in this. So it's a government access to keys like GAK, that's short. And here's what the idea is that let's say you are a software company that creates a product, or a hardware company that encrypts your data, and you want to keep it private. So if you want to keep it a secret, it's usually it's your stuff, so you want to keep it a secret. Well, what if you come in a crime, and what if you've committed treason and you are under the investigation by the FBI or police, and that information may not be as private as you thought it was. So what this is, that the software companies will give copies of their keys to the government. Now the government is responsible to keep these keys not accessible or usable. They just keep them in a key, and sometimes the third party within the government or a third party key screw that these keys can be used when necessary in order to uncrack something, so that they can. And so if it common times, if there is a court order or warrant, and that is obtained in order to be able to use that. Now we have had this process in a place for longer than you might be aware, and it certainly started after the 9/11. So this was enhanced, and even more was put into this. And let me give you one of the argument that has been and how people have gotten around this. So there are encryption method and communication methods where the government does not have access to these keys. It is still going to be an argument, but there are some of the secure program that the government cannot decrypt, they cannot monitor, or not they cannot check. And there is a challenge right now that with terrorism being utilized on these communication channels, that there are the people that created that communication channels for a different, and someone for something for terrorist who can communicate, and for that reason that cannot be monitored. So if it's so that they believe that your privacy is your privacy, you have the right to keep your data secure from prying eyes, and regardless of who that is. Now whatever you whichever seated your argument, you might kind of lean toward those sides of correct. The government wants access for criminal activities, which makes a lot of sense. But with all of our activities being on online or electronic devices or our phones or tablets and all kind of stuffs, this is a challenge today, and this is a communication across the internet. However, there is also some rights in the idea that I have some private medical records, and I have something that I don't want someone to see or know. So according to that, they don't have that authorities. Now there is another example of this that I want to clarify, and there is a one little bit recently, like Apple has been under security because the FBI has had a phone that they need to be cracked, and they cannot because they don't have the way to crack it. So Apple usually helps the government, so the other company that are opened up their phones in, and there is a court order. And in this case there is a little bit different. What the FBI needed Apple to do was not just to pull the data out of the encryption that they would already put on, but they also wanted to backdoor return into the operating system. This is something that doesn't really already exist, and it created a weak point to the encryption. So the Apple argumented is that if we do this for you, it's immediately going to get out, it will be risky, and it's going to get hackers, and they are going to be able to crack into anybody's phone in real time because of the backdoor, and there is a very big concern. The FBI's position was that we need to get to the data of the phone, and we don't know how to do it at that moment. So fortunately this argument kind of settled down when the FBI did find a third party that could crack the Apple phone and get the data off. However, you can imagine this argument is going to continue for some time, like many years, as you talk about. I think the government access to the keys, be aware that there will be an ongoing discussion with everybody, and it's going to be so long, and it will continue to be like this. But this is generally the idea of a government access to the keys. So PGP stands for Pretty Good Privacy, which is invented by Phil Zimmermann in 1991. So web trust is where you don't have a centralized PKI environment, but you want to exchange the certificates. So you want certificates to work just as you would. So you authorize within the group of people so that you can exchange certificate. So we do that is by using the PGP and use it for the data encryption and decryption, and also it was used for signing. So you can use it for encrypt files, emails, and one of the tools, that's why I am bringing this up. Again, one of those tools I am going to talk about is disk partition encryption tool that uses PGP for it, and there is a great history behind PGP at that time when it came out at 1991. Getting a good encryption was at that time was pretty tough. So this encryption that necessarily the government didn't have any access. So what we talk about that the government access the keys because you are using it with your friends, but the government is not involved. So one of the challenges is this, that there was going to be better encryption that were allowed to be exported, but PGP was designed to provide the four aspects of security like privacy, integrity, authentication, and non-repudiation in the sending of email. And PGP uses a digital signature to provide integrity, authentication, and non-repudiation, and it uses a combination of secret key encryption and public key encryption to provide privacy. Therefore, we can say that the digital signature uses one hash function, one secret key, and two private public key pairs. So it is an open source and freely available software package for email security, and PGP provides authentication through the use of digital signature, and it provides confidentiality through the use of symmetric block encryption. Also, there is some disadvantages of PGP, like the defined version of PGP complicate the administration, and both the sender and the receiver must have compatible version of PGP. For example, if you encrypt an email by using PGP with another of the encryption technique, the receiver has a different version of PGP which then cannot read the data because there is no compatible between this and the previous version. PGP is a complex technique. Other security schemes use symmetric encryption that uses one key, or asymmetric encryption that uses two different keys, but PGP uses a hybrid approach that implements symmetric encryption with two keys, and PGP also a very complex, so it's a less familiar than the traditional symmetric or asymmetric method. And the final part is that computer administration face a problem when losing their password. So in such situations, an administration should use a special program to retrieve password. For example, a technician has physical access to a PC which can be used to retrieve password. However, PGP does not offer such a special program for recovery, and the encryption method which is very strong, so it does not retrieve the program password. In a result, it lost messages or it lost files. And For this topic in this module, I wanted to talk about the side channel attacks, and I have to say this parts the basic of this. Even it makes my mind shudder. And really what this is a physical attack on a cryptographic device, and here is what I mean as a physical attack. So this is a piece of a hardware that we are attacking, and that's doing the cryptography, and we want to find a way to be able to attack this device to figure out what information is being sent. So here's what unique about it, and this sounds kind of strange, and the attack is based on how the algorithms are implemented, not on the algorithm itself. So instead of attacking the math, attacking the algorithm and trying to figure it out what we are actually trying to do, and we will listen to the device and see if there is a non-direct way to understand what's going on. Now I have an example here, like there is a ways to do this, like power consumption, and we can do what's called a simple or differential power analysis, where we can determine and generate through these algorithms and choose up more power. So maybe there is a power consumption method that when it's working through the algorithm, we could start to detect and check the changes and those who what I mean. And this gets really strange with a major variation of the electromagnetic field on a chip as it's doing the calculation, and from that some additional hope that there will buy the light, and there are people that can buy a monitor to broadcasting itself against a wall, so they can be shifting a light against the wall to see what's actually written on the monitor. This is how kind of works. We are attacking not the algorithm, but we are attacking the device to finding the weakness of this device, which is the real goal. So acoustic attack, and this is one of the best example I can give you, because I think this is really kind of comes in. So do you remember the old rotary phones? I think probably not, but here is a very simple one which I actually did is as you just studied a long ago, you could tell by the clicks of the somebody was using a rotary phone. So you could just tell the clicks when it's snapping back, what number they dialed. So if you have listened to somebody as they are dialing a number, you can write down the telephone number is, and there is a side channel attack. There is one thing, that particular thing about the keyboard, anything that emits sound. You may have been saw a war games where anyone is using a coin to bottle up or something to try to connect a phone. So it used to be the old days. You could whistle into the phone just like the modem does, and you could make connection to the system this way by whistling through it. And there is also a way to even open up phone and allowing it to dial the long distances without the recording it. Now these methods don't work anymore. These are the old phone things that used to be able to be done previously, the old time, but these days to exploit it through the sound and all kind of stuff. So for this is the side channel attack. The more of the story is we are attacking the device, not really the algorithm. And so you can imagine the science involved in this, and trying to figure out a way to detect how to crack on what's going on, and one of these methods, and it's definitely a interesting thing to check and analyze. This is something that you might actually get really interested to do even within your studies, or even if you are more interested, then you can research it even more. But there is a lots of way that you can dive further into the side channel attacks. So the digital signatures are a way of proving that the message came from a particular person. So this was a part of the non-repudiation, that the person cannot say later that it didn't come from them, because it uses their certificate and uses their signature to create it. So both requires authentication and it gives us non-repudiation. And I didn't do though, but it was actually related to a set of algorithm or standard, and I just wanted to kind of find out the point and figure out the couple of things. So DSA, which stands for digital signature algorithm, this is for the generation verification for digital signatures, and the standard that is under the federal information, which is processing and standard FIPS 186, and you will be a documentation out there on this. So if you start to look it up, one of the currently release is FIPS 186-4, which came out in 2013. Now this is a K generation process that we can do for creating both public and private key pair. So you get a lot of benefit out of this. So the best benefit is that it's a lot of better than the handwriting signature that's very easy to forge. That's one of the idea behind this, is that maybe, as an example, Mary has sent me a paper note that said you are fired, and which would not be nice for Mary to do, but it signed with Mary's signature, but that could have been forged by anybody. This gives us the non-repudiation aspect. So if you actually got an electronic message from Mary that says you are getting a pay raise, then it actually came from Mary. This way it verifies the identify of the signature and the integrity of the data, which is the idea here under the standard, and it makes it really easy for businesses to do the transactions. But I want to point out something out that I have, that one of the things with cryptography is that if you don't use it properly, then it kind of reduces the effectiveness, and this can actually get out of control. And I am remembering the part of the DSA, well, there is a elliptical curve, which is digital signature algorithm ECDSA, that the part of this, and you have to make sure the keys are that one you are using are regenerated every time. So it used, or there are the ways during the transaction that somebody can start to figure out what key is in it, therefore unravel the whole thing. And if those keys aren't regenerated properly, then the problem happens. And it actually, as an example, it actually happened with Sony's PlayStation 3. So there were their game, and all game were regenerating, and they were using the same key over and over again, and then all the game keys got hacked. So yeah, it happened a lot of people. It is similar cases like this. So one of the things is not just with the DSA, but with any types of encryption that you are working with, you want to make sure that you are implementing it properly and following a proper procedure, or it can crumble on you. So we add a couple of conversation and a couple of technologies to what you learned from the previous lectures. Now what we talk about is one of the things that the government access to keys. This has become a huge topic right now. That's something you as a security professional can get involved with. today. We are also looked at the DSA and the related signature schemes. We have to talk about the digital signature, and I wanted to give you some of the standards that apply to that and the kind of information that is sure are importance of the implementing your cryptography, and when you use it you're gonna understand. And one of my favorite thing is the pretty good privacy, PGP. First of all, the name is awesome, but this has been around for many long, like 1991, and used with the web of trust. And this is one of those areas where that applies the conversation on the government and whose government access the keys. So next I'm gonna point out a tool that uses PGP. So just wanted to mention about the side of channel attack, those physical attacks on the actual crypto device itself, not the algorithm but the device itself. So discovery on this and figure out a ways to crack information without cracking the algorithm, just by cracking the device and how it implements the algorithm. As you know here, heat signature, electromagnetic light, whatever it is that it are using, it is better to implement that algorithm without cracking the device, just by cracking the algorithm. So I hope you found this additional information useful and interesting. So add this to your collection of the cryptography stuff, but don't stop now. And in fact, in future you are gonna able to use this information very easily. To further understand a lot of cryptography stuff, I want to give you some of the additional tools and explain to you the documents that I have put together for you. Whether you are just getting started in your security or IT career, or you have been doing this job for quite a long time, one thing is that you are going to able to need to do and manage the remote machine in your work. So here's what I mean by that is, if you want to connect to a remote computer, and it doesn't matter if it is Linux or Windows, they both have these similar capabilities. So if you want to connect to that remote machine and execute commands on the remote machine to do the things and the remote machine, so you need to do some certain way. Now this may not have anything to do with cryptography, but as you are doing on the remote machine, this could be something like a ordinary management or configuration tools. The key here is though I can do it and I have to do it in securely, so I don't anyone to sniff around in the middle of the task. So what commands I am in thing that I am writing in the remote machine, so it can be done in securely. So one of the ways we can do is on the Linux based system, and you can also use the same thing on the Windows system as well. So it is called SSH or secure shell. So what is this a program is basically what provides secure remote control command and execution, then file transfer from your machine to a remote machine. And what you do is the uses of the basic command. You can do like man ssh to see more about this, but if you SSH and you give it to a remote machine, what on the machine is your username at that machine name, then you will be prompt you to use your password, then you will have to gain the access of the machine. So if you run an ls command and that command is running on that remote machine, and it will be done securely, so no one can sniff around middle of your work. So we have a secure protocol for SSH to make sure that nobody is sniffing in the middle. Now this is a replacement for the older utilities. You may hear people talk about like using telnet and some other logins. So the other older utilities that they used, and now they replace it with SSH on Linux and so it is a very common way to manage the remote machine and access remote machine for a variety of reasons. In fact, one of the most common thing you will hear from both the Linux guys and the Unix guys are, let's SSH to the box and do something to it. Now, one of the things is, while you can get the program to offer the SSH capabilities on Windows, Windows has its own application to run this. So Windows has this own built-in management tool called PowerShell, and PowerShell has a part of is called PowerShell remoting, and that's similar to the SSH. It works a little bit differently, but it gives you the same kind of concept where if you enter a command or ls session for a computer name, it can send a different credential for authentication. So if I want or is going to use the credential, then I correctly have my machine and it will connect to the remote machine. Then after that you can just execute commands from the remote machine to do whatever you do. The important part to this is that you will be working in sort of shell, whether it's a bash based shell or something like that, or like in Windows PowerShell, you are going to need to be able to connect to it in remotely. So the important thing is that it's all done securely and nobody can sniff around what you are doing and what things you are executing. So that's what SSH does to primarily on Linux, and PowerShell remoting does on Windows. We spend a lot of time talking about the integrity of data and how we could do that. And one way to do that is with hashing, and we talked about some of the different hashing algorithm, and I used a hashing example. So you might recognize this screen where I changed a text file, and firstly I with running an MD5 algorithm. So as just to show that a number get changed, so you could tell if somebody had modified a text file. So if you wrote a text file and got to the hash algorithm and you run it and you got the hash for it and went back and changed it later and the number was different, so it got changed. And in this example, to show you the number, I was using the Windows PowerShell, and Windows PowerShell has a built-in command that you can use to call get dash file with hash. Now it's a little bit, so I'm gonna give you a document that gives you the other program that you can use for hashing, but I just wanted to know that you have that one and build right in it and let you use the variety of different protocols. Now that what I thought was I had written my own version of this and changed and what it displayed, because I was using more of a like research or learning tools. The version that I wrote was called get my file. dot hash. So it would let you give a path to a file, or you could get a collection of files that you could take more than one file then, and it would display all the algorithm like MD5, SHA-256 and up to SHA-512. So you could see the difference if how this hashes look for what you were using. Now I could show you this, but unless you are into PowerShell, the code doesn't make a lot of sense. So what I wanted to do was to give you the module and tell you to install it. So if you wanted to play with this now, you can do that, and if you are into PowerShell, please feel free to go ahead and look for the code, and that's in the module, and feel free to change it, and you can change or modify or make it in your own. So you can just download a folder like hash.zip and copy the hash folder to C program files under PowerShell and modules, and there is a space between there in program file. So copy the folder out there, and there is a place where you can write your own PowerShell module, and those modules in those commands or functions that you wrote in there module will available for you when every time you open up the PowerShell session. Now I wrote this so that can help you understand how to use it. So I put in some help and some examples. So once you have copied out there, and you can do the like get dash my file hash dash space dash detailed, and it's gonna give you a bunch of information about what it does, and there is a couple of examples in there to how to use it. So you can just start looking at files and getting results right away. You don't have to code yourself anything in this case, just feel free, and if you are into it, you just try it and change it and switch it as your own need. So do whatever you need so better you can understand it better. Do it every and every other way you can. And having said that, there is a one way to be able to work with the file hashes and take a look at it, and it's a very I would say learning tool for that. One of the challenges that I have always had learning anything, not just cryptography or anything else in security, that the concepts are difficulty to grasp unless you put your hands on it, and especially in computers it's always been sit down and work with it, actually to do it, and that will help to further understand the concept and input things together. So one of the best things is to further advancement of the studies to work with the tools that help you to learn more about this. So I've created a document for you. This is a list of several tools, and like I didn't mention before, so it's not the ultimate comprehensive list but gives a great list to get started, and when you use the furtherment of your understanding. So I have broken up into a section that you are seeing in this slide for the ethical hacking stuff. So anytime you use any of the tools out there, try to make sure that you are running them in a very isolated environment, because to fully aware of what they do. And you can set up anytime a virtual machine that you help an isolate mode, where it's not talking to the other network or not even your other virtual machines and even your own computer, but you need to always make sure that it's isolated. And if you happen to start studying things like viruses, worms and stuffs, you want to completely isolate different systems that can be destroyed completely from the ground up. This kind of stuff that you are working with these tools. The other thing I want to point out is that if you work in an office and some of the offices uses this ethical hacking and crypto tools, but also some of the companies are against this policy. So there's a lot of companies that running of these tools of ethical hacking and these crypto tools, but a lot of tools aren't against their corporate policy. So you need to check in your company's environment. So please very careful when you work with these tools, and please check what you're going to work, and if you working with this you need to get approval of this. So the tools that include different categories, like if you want to have some hashtag, in final integrity is very important, and I want you to able to explore that not just with the tools that I gave you, but some additional hash tools that will let you check out the hashes, or even the couple of tools that you try to crack or older hash or something like that. So you can get the idea that how this is going on. I also want to have some cryptography tools, like actual encrypt stuff that like cryptography tools that might be important for your life, like as an example, like encrypt your disk and the tools that encrypt your files from the hard disk, and even encrypt a message for you. So things to look at, and you can look at it, and it will also help you to understand some of the algorithms and how the algorithms work, and the disk encryption tools that help you, and you can work with encrypt your disk, and one of those uses PGP. So it usually encrypt your volumes and manage system where you want to have a disk encryption. Also, I want to give you some of the tools on crypto analysis where you can study some of the algorithms and how they work there, and a couple of get rules out there, like one of those things you will see in a great online tool, like help you to educate you. And when you look at the document, so what you're gonna aim with the tool is that you're gonna see a short description of the tool and what it does, how it works, and the link will take you to the tool in the online. Now I'm going to talk about of these tools that are free, but some of them are paid tools, so that will require developers to develop on them, so you need to pay some of them. So they are not all free, but even the ones that you have to pay for, they are not very expensive, so you can just decide for yourself if you want to take a look at them or not. Maybe talk to the other friend of yours who are the same minded as you, and they might use them. So the goal for this module was to provide you with some tools that bettering your education for cryptography, and I think it helps a lot when you get a chance to actually accept working with it and put down your hands on it and start to take some of these concepts that can be confusing and put them to in good use. Now there is an additional thing that you can do beyond this building, so your own PKI environment and working with the certificates, but this will at least get you started. We should to look at the SSH and for security shell. So if you are in a Linux based environment, you're probably already using SSH, but the important part is that you don't use tools to manage remote server that are unsecured. You always want to use security tools for your own purpose, because, and a great example of this is you can do the same thing on Windows if you are managing Windows machine by using a PowerShell remoting, and this is a tool that will get your file hash so that you could explore the defined algorithm, and the result that you are looking at the files that are half, but also wanted to make sure that you had a document that included hash tools and other crypto analysis, and those crypto analysis tools and cryptography tools, so that you can explore your world. And I always encourage you to go further and beyond this and exploring cryptography. There is so much more to learn out there about cryptography, so you just got to start in it. So then this is a great way to get started by moving forward a little by little. So I think you'll really find cryptography fascinating, and the rest of the ethical hacking information that you are getting. And it seems like a lot, but it's a very good for the security professional.
Hello everyone, let's talk about cryptography techniques and cryptography. So cryptography dependencies on the OpenSSL C library for all cryptographic operation. Have a look in this picture. Cryptography related symmetric key cryptography, asymmetric key cryptography, then symmetric key, down classical, and other asymmetric key. OpenSSL is the fact standard for cryptographic libraries and provides high performance along with various certifications that may be relevant to developers. A list of supported versions can be found in our installation documentation. Just give command OpenSSL version. The OpenSSL project develops and maintains the OpenSSL software. Give command OpenSSL list cipher commands. Here is some command. Cryptographic protocol that Netscape released in 1995, and this protocol layer can sit atop HTTP, thereby providing the S for secure in HTTPs. The SSL protocol provides various security services, including two that are central in HTTP: peer authentication and confidential identity. Peer authentication is a side of a connection authenticates the identity of the other side. If Alice and Bob are to exchange messages over SSL, then each first authenticates the identify the other. And confidentiality, a sender encrypts messages before sending this over a channel. Now give command nano message and set a message in SSL service. It returns SSL support message integrity, which assures that received. Let's give message hi everyone. A received message is the same as the one sent, and this feature is implemented with hash functions. which likewise come with the OpenSSL toolkit. SSL version and SSL version 3, and in 1993 Transport Layer Security TLS emerged as a similar protocol based upon SSL version 3. And OpenSSL is descended from the SSL library developed OpenSSL. The OpenSSL recommend line tool, a switch army knife for cryptographic tasks, testing and analyzing. It can be used for creation of key parameters, creation of X509 certificates, calculation of message, digest, encryption and decryption, SSL TLS clients and server tests, handling of S-MINE. Although testing and development could in theory also be done using the source tables, having a local copy of the Git repository with the entire project history gives you much more insight into the code base. The official OpenSSL Git repository is located at git.openssl.org. In today's networked world, many applications need security, and cryptography is one of the primary tools for providing that security. The primary goals of cryptography: data confidential, data integrity, authentication, and non-repudiation. Repudiation can be used numerous types of network-based attacks including eavesdropping, IP spoofing, connection hijacking, and tampering. OpenSSL is a cryptographic library. It provides implementations of the industry's best regarded algorithms, including encryption algorithms such as 3-DES, BES, triple DES, AES, and RSA, as well as message digest algorithms and message authentication codes. Using cryptographic algorithms in a secure and reliable manner is much more difficult than most people believe. Algorithms are just building blocks in cryptographic protocols, and cryptographic protocols are notoriously difficult to get right. Cryptographers have a difficult time devising protocols that resist all known attacks, and the average developer tends to do a lot worse. For example, like this, many more command, and after message received, then give command OpenSSL encae 525ccvc Just look carefully this command and try by your own. For example, developers often try to resource network connections simply by encrypting data before sending it, then decrypting it on receipt. That strategy often fails to ensure the integrity of data. In many situations, attackers can tamper with data and sometimes even recover it. Even when protocols are well designed, implementation errors are common. Most cryptographic protocols have limited applicability, such as secure online voting. So this is the basic command. Crypt, secure encryption and decryption of files and streams, uses modes and options. Like you guys can encrypt, decrypt, can decrypt files to std out, change key, decrypt old Unix crypt files. Ultimately, it would be nice if developers and administrators didn't need to know anything about cryptography or even security to protect their applications. It would be nice if security was as simple as linking in a different socket library when building a program. The OpenSSL library strives toward that ideal as much as possible, but in reality, even the SSL protocol requires a good understanding of security. Indeed, most applications using SSL are susceptible to attack. Nonetheless, SSL certainly makes securing network connections much simpler. Using SSL doesn't require any understanding of how cryptographic algorithms work. Instead, you only need to understand the basic properties important algorithms have. Similarly, developers do not need to worry about cryptographic protocols. SSL doesn't require any understanding how to apply the algorithm properly. The goal of this is OpenSSL library and how to use it properly. This is classical cryptographic schemes, simple substitution zippers. So that's it for today, guys. I hope you guys liked it, and thanks for watching.